Hello everyone, can you hear me? Can anyone confirm you can hear me or not?
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. I see some new people here. I think, okay, Kirtika, thank you. Um, Sweta is new, Jayaprada is new, right? They were not here in the previous class. So, can you introduce yourself?
Yes, sir.
Like, I want to know, like, what are you, like, what background you are from, like mathematics or anything else, or what are you doing right now? Can you tell me? You can like write hi Sweta. Studying MSc Maths. Okay, nice. And Jayaprada,
Sir, I am a mathematics teacher, sir, lecturer in junior college.
mathematics teacher. Okay, nice. Thank you.
Yes.
Thank you. So what happens here since you are uh, joined in this third week? So we go through assignments of the previous year so that it helps you solve the assignment this year. I hope you have gone through the lectures, actual original lectures from the NPTEL website. Uh, this week we will be solving week 3 assignment of the previous year, and if you go through the this year's assignments, you will find the similar questions, so it can help you solve it. And what we will be doing here, that you have to solve it along with me. Like, I wouldn't be solving all of them, I will be giving hints uh, and how to solve those and have a discussion. So it will be a interactive way that you will have to answer and interact with me, ask questions, and do calculations. I hope you have some like pen and paper with you, but you will need to do some calculations and stuff. There is someone. Okay, so it will be an interactive session. You can either unmute yourself and answer and discuss, or you can write in the chat whatever you feel like, but you should interact. So this is Jai Roslyn. I think uh, uh, you were not there in the previous week.
Yes, sir.
Okay, so
I couldn't attend, sir.
okay, fine, that's fine. I'll just give you an introduction. So, can you tell me about yourself, like what kind of course you are actually in, or what's your background?
Actually, I'm working as an assistant professor, sir,
Okay.
at St. Joseph's College, Tiruchirappalli, Tamil Nadu.
Okay, thank you. Nice.
Yeah, okay, sir.
So there are a few teachers. You are not the only one. So I'll introduce myself to you. Like, as you can see, my name is Sahil. I am a PhD student in IIT Hyderabad. So I am a physics student. I come from physics background, and I work in mathematical modeling in biological systems and stuff. So I am the TA here. So we will be have a discussion, and I hope you interact. Okay. So
Yes, sir.
let's shall we start? It's 3:12. I think this this week most
Yes,
of
sir.
them are new. Okay, fine. So have you gone through? Have you all gone through the lectures of week 3? Like slides.
No, sir.
Okay, then it might be a little bit difficult. Not difficult. Like, I will be giving hints and you will be understand, and I think you all have some basic idea because you are some teachers and MSc mathematics students are here. Let's see how it goes. Okay, so let's go to the first question. So these are previous year's assignments. So this year's assignments will be similar. So first question is, which of the following statement is false? So an ODE has only one independent variable. Tell me, what do you think? An ODE has only one independent variable. Is it correct or not? Option A.
Correct. First one is correct. Only one independent variable.
First one is correct. Only one independent variable. That's what ODE is.
Right.
Next one is an ODE has only one dependent variable. Of course, this will be the wrong one, right?
Yes, sir.
And PD has more than one independent variable, and both ODP and PD can have more than one independent variables.
Independent variable. Correct.
No, sorry.
No.
This is also correct. ODE has only one dependent variable, right?
Independent variable. Right.
Yes. So one independent, one dependent. Third option is a PD can have more than one independent variable. Is it
That
correct?
is also correct.
Yes.
Yes. Correct.
It is also correct. Both
Correct.
ODE PD can have more than one independent variables. So
Wrong,
here is
that is
definitely wrong. Yes. Everyone got it?
Yes, sir.
Sir, actually, in the second option,
Yes.
a system of ODE can have more independent variables, right?
Correct. But it says an ODE, like one ODE.
Anode.
Yeah.
So one ODE, so it
With
is.
one dependent variable, one independent variable.
Okay, sir.
Yes. Fine. Next one is question 2. And you want to say anything? No. Which of the following statements true about non-dimensionalization process? So you know about non-dimensionalization process?
Non-dimensionalization.
So when you have an OD, suppose for example, suppose simple, let's say dx dt plus p x plus q equals 0. This is an OD. So here suppose I say this x is length and t is time.
Okay.
So these are called dimensions,
Yes.
right? So when you non-dimensionalize an OD, you make all the variables to not have any dimensions. Okay? So the first option is it is used when equations are dimensionally incorrect, which is not true, because you can't, if the equation is dimensionally incorrect, you can't do any dimensional analysis there. Like assume that this dx dt, this px and this q will have the same dimension, that's why they can make an equation. Okay? Okay. So which of the function is true? So it is used to reduce the number of parameters and variables. So when you non-dimensionalize it, anyone knows how to actually non-dimensionalize?
No, sir.
No, anyone else?
No, sir.
No. Okay. So I will show you one question which does have. Just we will come back to question 2. There is another question which involves, yes, let's say this equation, the same equation I wrote, question number 6. Okay, so I will show you how to non-dimensionalize it. So p dx dt plus q xt plus r equals 0. p, q, r are parameters and xt is the variable. Okay, having some dimensions. What will be the minimum number of parameters possible after non-dimensionalization? Okay, so these p, q, r are parameters. Now you have to non-dimensionalize it, and the question is what will be the minimum number of parameters available after non-dimensionalization. So let's say, how will you do it? So suppose you have this p dx dt plus q x plus r. You start with rescaling these variables. You have variables x and t. This is dependent variable, this is independent variable, right? So you write x as some constant times some non-dimensionalized variable. So this is a
అమ్మా
constant.
వైష్ణవి చెప్పమ్మా.
Yes. You said something, Jayaprada?
No, sir.
Okay, okay,
No, sir. No, sir. ఒక్క నిమిషం ఉండండి.
okay, come.
చెప్పమ్మా.
Hi, Tejinder.
Hello, sir. Good afternoon.
Good afternoon. So we are discussing about non-dimensionalization. Yes, yes.
Okay. Okay.
You said something.
No.
Okay. So we are discussing about non-dimensionalization, and we are at question number 6, but they are like we jumped from question number 2 to question number 6.
Okay.
Yeah. So to non-dimensionalize the variables, we start with the variables. So x is the variable which have a dimension. Now we rewrite this x as some constant times some variable, where this constant will have the dimension same as x, and this x star will not have any dimension. Similarly, we will write t as same t1 times t star, but this t star is no dimension but variable, and t1 is the constant with same dimension as t. Okay, so based on that, can you write this equation in terms of dx star d t star? Can you do like convert this equation in terms of this and tell me what do you get? Like you rescale this thing and you rescale this thing. You write x as this and t as this. Now remember, x star and t star are the variables, x1 t1s are the constants. So can you tell me, like can you do this and tell me what will be the form of this equation if you put this back?
Okay, we'll try.
Yeah, please try and tell me. Everyone please try. I think this is a simple calculation, not a very big complicated calculation. Just write in terms of dx star dt star. What did you get?
We got the same result.
Same result. Everyone did it or others please respond. If you didn't do it, that you can also tell me that you are having difficulty telling me doing it. So anyway, so this is our new equation, okay, where x star and t star doesn't have any dimension. So the variables have been non-dimensionalized. Now look at the parameters. So you can take r common, and for r non-zero you can write it this way: x1 by t1 dx star dt star plus q x1 by r x star plus 1 equals 0, right? Now see, these are constants, okay? So if you write p x1 by r t1 equals some new constant and q x1 by r equals some new constant b, a and b, so this equation becomes a dx star dt star plus b x star plus 1 equals 0, correct? Now look at this a and b. You can see they are related. How? So you see x1 by r is b by q, right? You can put p by t1 times b by q equals a, okay? Now this p and t1 and bq, these are arbitrary constant, so you can have, like, because they are arbitrary constants, you can reduce it to one single constant, and you can choose for any p to be t1 times q. So if you choose p, you can choose this because they are arbitrary. It can be anything and it wouldn't affect the system. So if you choose p equals t1 times q, so a becomes equals b. So your equation is reduced to something like this, right? So right now if you see this x star and t star, hello Asif, we are solving previous year assignments, please interact with us. So we started with a differential equation that have dimensional variables x and t and some parameters p, q, r, and via the process of non-dimensionalization we end up with an equation which have non-dimensionalized variables and only one parameter here in this particular equation. So now if you come back to these questions, given a differential equation, this p, q, r parameters and x, t is variable having some dimensions, what will be the minimum number of parameters possible after non-dimensionalization, assuming no parameter is set to 0 value. So we didn't set any parameter to be 0. So from 3 parameters p, q, r, we end up with one parameter which is a. So this is the minimum number of parameters you can get from non-dimensionalization. So you get the idea of non-dimensionalization, everyone?
Yes, sir.
Okay, so come, let's go back to that question. Now you should be able to answer this question 2. So it can't be, you can't non-dimensionalize an equation where the equation is dimensionally incorrect. What is the option 2? It is you should reduce the number of parameters and variables. So is it correct or not? Which is the question asks which is true. Now tell me.
We have reduced the number of parameters, but the number of variables are same.
Exactly. So number of parameters you can reduce, but number of variables you can't. So this option is also not correct. Next one. After non-dimensional process, no variables and parameters have dimensions. Is it correct or not?
Correct, sir.
Yes. If you non-dimensionalize the equation, no variable will have any dimension. That's the process of non-dimensionalization. So this is the correct option. Everyone understood?
Yes.
So I am moving to question 3. Which of the following statement is true? So let's go one by one. The first one says is a linear second order first degree differential equation. So you are familiar with the concept of linear or order of a differential equation or degree of a differential equation?
Yes, sir.
Can you tell me what a degree of a differential equation is?
Highest order derivative occurring in the differential equation is called as the order of the differential equation, and its power is called as the degree of the differential equation.
Yes. So highest power occurring is the order, and its highest power is the degree. And what is linear, non-linear?
If no powers are given for the derivatives and variables also, y also is there, that is called as a linear. If powers are there, then it is a non-linear, like y square, dy by dx whole square, like that.
So if you have a term like this, you tell me, if you have a term like this, will it, like, forget about others, just an equation with this kind of terms, what will it be linear or non-linear? Both have power 1.
X square quadratic is there. That's why it is not
No,
linear.
no, I'm not asking about this. I'm just saying, suppose you have some y dy dx equals x. Is it linear or
Then it is a linear.
it is linear?
No, sir. No, it is
No,
not.
sir. Non-linear, sir.
Okay, Vijayalakshmi said non-linear. I think J also non-linear. Anyone else having any other opinion? And whoever saying non-linear, why so?
Sir, linear means variable y and its first order derivative only will get, sir. Y and dy by dx only, sir.
Y or dy by dx?
The first order derivative will get, sir.
Sir, multiply together with the dependent variable is not allowed.
Yes, sir. They will not multiply, sir.
Ah, okay. So if it had plus, then
Sir?
suppose what is this right now? I think there is a lag. You can see this. I made a change.
Yes, sir. Yes, sir.
So is it linear or non-linear?
Now it's linear, sir.
Now it is
No.
linear. Vijayalakshmi, do you disagree?
No, sir. Yes, sir.
Why? So you are saying that this is non-linear now. Like, so let's say y plus dy dx equals x and y dy dx equals x. Which one is linear? Which one is non-linear? 1 and 2. Let's say 1 and 2. Tell me. Did I get disconnected or not?
No, sir, you are there. The
Okay.
first one is linear, the second one is non-linear.
So Tejinder is saying first one is linear or second one non-linear. Any other opinion or any other words to this?
Yeah, correct, sir.
Okay, correct. And Vijayalakshmi?
Yes, sir. Correct it is.
Correct.
First
Yes.
one is yes.
Yes. So it's not only
Okay.
dependent variables power. It's also you have to check if it is in a product form with the differential operator or not. Okay. So let's come back to this question. So definitely it is this first option is non-linear. So this is not the correct option, right? What about the second one? It is wrong because it is not linear. Just
Yes.
you can say it by looking at it. Third one. It's non-linear. It is correct. Non-linear matches, right? It is not linear because x dx dt is there, but degree is not defined. What about this?
Correct, sir.
Correct, because
Root 2 is not a number, integer.
yes. So there, I think
That's why degree is not different.
yes, degree will be always a whole number.
Positive integer.
Positive
Yeah, whole
integer.
number.
Yes. So this option is correct.
Yes.
Last option.
Sir,
Yes.
excuse me.
Yes.
Sir, I have one doubt here.
Okay.
In the third equation,
Hmm.
if I multiply on both sides by 1 by root 2,
Hmm. So that is
what
different.
will that?
Yes, Jayaprada is answering. Please go ahead.
Yes, sir.
You are answering to her question.
Question number,
Yeah.
no, this same question,
Option
option 3.
Okay. What is you saying, Jayaprada?
So dx by dt becomes again 1 by root 2, no? The derivative is also raising to the power 1 by root 2. That is also not degree, not defined degree.
Yes.
So far as the derivatives are concerned, the powers must be integers only, positive integers only. If we multiply both sides with 1 by root 2, then dx by dt power becomes 1 by root 2. That is not possible. That is not the degree. So that's why that statement third is correct.
Yes, that is correct. So you can't get rid of this root 2 that easily. So maybe highest power would not have degree, but then there will be x dx dt will have a power degree, and also that will represent a different differential equation. So which is a derivative, like which is derived from the same differential equation, but there could be the solutions, like the general solution can change in this kind of cases when you multiply this with by 1 by root 2 in both sides in concept differential equations. So that is why it is called not defined. Okay.
Yes.
And what about
Okay.
any questions, Jay?
Yeah, sir, now it's clear.
Okay, thank you. So last one,
It's correct, sir.
it's called non-linear.
Yeah, non-linear, correct.
Second order, right? Second
Yeah,
order.
d square x by dt square.
First
And its
degree.
power is also 1. Yes, both all are correct.
Yes, these are correct. So these two are correct options. Understood, everyone?
Yes, sir.
Okay, I'll go to the next question.
Good.
Okay, chemostat. Who knows about chemostat? Who
I
knows?
don't know.
Sir, sorry, sir. In the previous question, again, the fourth option, the coefficient of
Oh.
dx by dt.
Sorry, this is not the correct option. Yeah, you go ahead. You go ahead. Yes. Yes, you are actually pointing it correctly. So you see this term. Sorry. This term. It is. Does it make it non-linear? By definition. I think Jai is pointing out correctly.
Yes, sir. Product of independent variable
Yes,
are allowed.
yes,
Not allowed.
yes. So
For
this,
linear.
yeah, by definition, this is not. This is actually linear. If it was x dx dt, then it would have been non-linear. Correct. Thank you. Thank you for pointing out. Yes. Okay, so chemostat, you know or don't know? Which one? Anyone knows?
No, sir.
I don't know, sir.
Okay.
It is in the video actually, I
Yeah,
think.
it is in the video, and the uh, what do you call, the PPT is also there. You can, if you go through it, you will know it is. This question is mostly definition based question. Like there are some microorganism, so there is an influx of nutrients. So microorganism, and there is nutrients and outflux of nutrients. So you can write differential equation and see how these microorganisms population will change with time and all. Okay, so you should go through it. There is nothing. It is mostly definition based question. Like there is this concept called self regularization. I'll just give you the answer. Just go through the question. So self regularization means when the nutrients are more, it will accelerate the growth of the organism, and when organisms are more, they will compete. Just like some population prey kind of thing. So if there are more nutrient, it will help the microorganism to grow, because microorganisms consume the nutrients and grow. And when the organisms are more, so nutrients are less, so there will be a competition between organisms and they will compete. That's called self regularization. Okay, so uh, the second option, I think it is not correct. If the mixture of the microorganism and nutrient is not very mixed, non self regulation definition is different, and the other options are just the properties. If in order to keep the volume inside the chemostat constant, the rate of influx should be equal to the rate of outflux. So whatever at whatever rate there are nutrient going, it should come out at the same rate, because the inside you have to keep a constant volume. And if it is not properly mixed, this is an important thing. Uh, if the mixture of the microorganisms and nutrients is not properly mixed inside, it will make the mixture to be space dependent. Like suppose inside somewhere there are more nutrients, somewhere there are less nutrients. Okay, so what will happen, you can't write an OD, you have to write a PD. Like suppose C is the concentration of nutrients. Now suppose C can depend on X, Y and T, X, Y, Z and T. So what is X, Y, Z? X, Y, Z is the position where inside the chemostat. Now if it changes with X, Y, and Z and T, you can't have this kind of OD format. You will have to write del C del T, which will lead to a PD. But if it doesn't change, if you change X, Y, Z, like wherever you go inside your room, it is the same value of C. So there is no space dependence. Only time dependence is there. So if it is only time dependence, so C depends only on time, then you can have a OD model. So this kind of this on an example the professor gave to uh, to tell how to construct an OD from a given real biological system or real environmental system. Okay, so go through this question, what is chemostat, and you will get, this is given in the lectures. This whole question is the lecture, like 2-3 slides are there. Okay, so next question, I think you should try it. You know Taylor series expansion?
Yes, sir.
Everyone knows Taylor series expansion? So tell me, what is the form, like suppose I have f of xy, how to expand it in Taylor series around a point x0, y0. Jayaprada, go ahead.
I know only single variable Taylor series,
You
sir,
know
not
only
double variable. Single
single
variable
variable.
Taylor series
Fine.
only I know. Double variable I don't.
Yeah, yeah. Tell me about single variable.
F of f dash of x, sorry, f of x plus h is equal to f of x naught plus f dash of x naught by 1 factorial plus f dash of x double dash by 2 factorial. H plus f double h square by 2 factorial into f double dash of x naught and so on. Last f h power n by n f the nth derivative of x naught.
Something like, yeah.
Factorial f, yeah, that I know.
Yeah, yeah. Fine, fine. This is. Uh, so this should be x naught plus h, right?
Yeah, x naught plus h.
Yes, yes. Okay. So for two variable, it is kind of similar, and
Oh,
you say you
okay.
see this is called linearized form. So we'll write till this linear part, like of linear power of h. Will not like there is the whole expansion, and acha, if someone knows this, just do it. Okay. So I am discussing it for who doesn't know how to do it. So tell us, just do it and tell me the answer. Okay, just parallelly go ahead. So you can expand in Taylor series with multivariable also. It is same like f of x0 y0. Suppose you are expanding around x0 y0.
Okay.
Plus if, like, let me write it this way: del f del x at x0 y0 times x minus x0.
Oh, partial derivative. Okay.
Yes, plus del f del y at x0 y0 times y minus y0. See, this x minus x0 is actually your h. Here you write x equals x0 plus h, then h equals x minus x0 here. So x minus
Yeah.
x0 is your actually is your h. Why? Plus in same way you will have higher order terms.
Okay.
Now do the calculation and tell me which is the answer. So you have to do it for around 1 comma 0 line.
Mm.
Everyone, I have given the equation. Just tell the answer.
X naught y naught is 1. Del f by del x is y plus 2x 0 plus 1 comma 2 into x minus x naught x minus y dou f by y x plus 2 x 1 y minus y. So f of xy is approximately equal to 1 plus 2 into x minus 1 plus y plus so on. So that is 2x plus y minus 1. 2x plus y minus 1. Second option is the answer.
So two people, I think Jayapradan, Tejinder got option B. Anyone else trying? Jay, Vijay Lakshmi. Anyone? Kirtika, are you trying? Just do the derivative, put the values. I think option B
Yes.
is the correct answer.
Right.
I hope you are trying because it is not a big that complicated a thing. I will move on. Please do try. Okay. Okay. Question 6 has been already discussed.
Yes, sir.
Yes.
7.
Let's go to question 7. So same again, non-linear, linearity, and solution of differential equation in those lines. So first question, first option, it is non-linear and can be solved by method of separation of variables. What do you think? Is it non-linear or not?
Yes, yes, sir.
Yes, it is non-linear.
And it can be solved by separation of variables.
Yeah, variable separate.
Yes.
Y dy equal to x dx.
Yes. So it can
Yes,
be
sir.
Correct.
solved. Okay.
Correct.
So this option is correct.
They are asking incorrect.
Yes, they are asking.
They are asking
Incorrect.
incorrect.
Yes. So the general solution of the differential equation represents family of circles. So let's calculate the solution of the differential equation. Okay. So go ahead, do it. So go do separation of variables, then calculate the general solution. See all the next three
This
answers
is not
are
circles.
yes.
Pi square, not circle, sir.
What did
It
you
is a
get?
hyperbola.
What did you
That
get?
is a hyperbola.
Hyperbola. Okay.
Right.
Saying hyperbola.
It is
So
not circle.
what did you get as the answer?
Because y square minus x square is equal to constant we are getting.
So we get x
Yeah.
minus y into x plus y equals to 0.
Y square, no.
Okay.
That only x square minus y square equals to 0.
Not zero. Yeah, conditions are
So
not given.
they are
It's constant. Yeah, passing through
They
the
have
horizon.
given the point, no, sir?
No,
Center is
circle. For circle only is the given.
Yes.
With hyperbola,
It is
that's
straight line.
rectangular hyperbola. No, it
Yes,
is a
sir.
rectangular hyperbola.
Rectangular hyperbola, correct, sir.
Right.
Okay. You had your discussion and what did you decide?
Y equal to x square. Point is not given. Oh.
So is it hyperbola?
Yes, sir.
Yes. So
Yes,
this
sir.
is
Rectangular
Rectangular
Correct.
hyperbola.
rectangular hyperbola.
Yes, yes.
Okay. Is it circles? Family of circles?
No, it is not
So
circle.
this is wrong. And one of the particles in the differential represents straight line. Is it?
Yeah, if it is passing through the horizon, then it becomes pair of lines.
Yes, sir.
Yes. So these two are correct. Like it should be
Yeah.
actually.
So the answer is second option.
Answer is second option.
Again,
This
answer
the
is second
yes,
option.
Yes.
Incorrect one only they are asking.
Yes, correct. So this was easy. Everyone agrees?
Sir, wait, sir.
Yeah.
I'm writing.
This assignment is mostly differential equation and you all know how to do it. So now it's Jacobian matrix. Stability analysis. Do you know how to do stability analysis?
No. Jacobian.
Yes. In the previous lecture there was a concept of Jacobian also. And here
Okay.
also there is a concept of Jacobian. Do you know how to do function of the principle of so for this question you don't need to know the Jacobian, like calculate the Jacobian, but you need to know the theory of it. Okay.
Oh, okay.
Okay. Question number 9 and 8 we will be solving together, but before that, okay, let's forget the option 1. Read the option 2. The physical meaning of doubling time is the time at which population will reach to exactly half of the final population, steady state population. You have a concept about population changing, concept of doubling time or half time. You have or you don't have? Okay, I guess that is a no. Third option, a linear function obeys the principle of superposition. Is it correct or not?
Yes.
Yes. Okay. Someone left. Okay. So this option is correct. Linear function obeys principle of superposition. Okay. And option D, what do you think, is it correct or not? Steady state solution means after some instant the change in population size will be 0, that is real equal to 0.
Yes.
Yes, that is called steady state. What the steady state means, the population is not changing. So this is option is also correct. And what about the first two? Second option is more like a definition based question, where actually this is wrong, because you don't know. Suppose you want to define a time based on how population is changing, how population is decaying. Okay, so you don't know what is be the final population, so you can't define anything based on the final population. So it is actually based on the initial population. So this doubling time, it actually means, suppose you start with a particular n population, and at what times n becomes 2n or n becomes n by 2. Suppose the population is increasing, like at what time it becomes double the initial, or at what time it becomes half the initial. That's how you define a doubling time or a half time. Okay, so this one is option is incorrect. And I will come to the Jacobian concept. So there is this info, like, since I have time, I usually don't go into details of theory, but this week we have time. So I'll go to this concept of linear stability analysis. Do you know what linear stability analysis is? Do you know about this? Anyone?
No, sir.
Yes. Okay. So I'll just go through the. Suppose you have two variables, x and y. So it can represent anything. It can represent two population. It can represent two concentration, or anything. So sorry. It can represent anything. So change of x with respect to time is defined by a function which depends on both the population of x and y. Okay, and suppose change of y is also defined by a function which depends on both an x and y. Okay, so this is called system of linear equation coupled, because x change in x depends on change in y. Fine. Now you want to see what is the steady state or fixed points. So at what it is defined as, at what x and y, suppose for x, which x star y star dx dt equals 0 as well as dy dt equals 0. This is called steady state. Like if the population have exactly x star amount of x and y star amount of y, then there will be no change in the population. Okay, so from this you can write f of x star comma y star equals 0 because of this differential equation, and g of x star comma y star equals 0. Okay, so solving this you will find out at what x star y star values. Like if you solve this, you will get x star y star steady state or fixed point, just like the previous difference equation cases. Now you want to test this x star y star are stable or not. So the question is x star comma y star stable or unstable? What do you mean by stable or unstable? That means if you were really close to x star y star, will the system go away from x star y star or come towards x star y star? Like for example, suppose you are on a hill, okay? The hill looks like this. If you are exactly at this point, will you move or not? Just answer from your experience. Hello, are you guys there?
Sir, please repeat that one.
Yeah, we are listening.
Yeah. Suppose you are on a hill that looks like this, okay? This one. Now, suppose you are here exactly at this point, at the top. Suppose not you, suppose there is a block, okay? One block is at this point, one block is at this point. Will they move or not?
Yes.
They wouldn't, right? They will stay.
Yes.
Suppose one block is at here, will it move or not? It will fall down.
Yes, yes.
Yes. So this is not a fixed point, but these two are, because if you put something at exactly that point, it doesn't move. Okay. Now you want to check if these two fixed points are stable or not. What do you do? From daily experience, what do you want to do? If I am asking this, it is stable or not? The block or the stone or anything is there at equilibrium. It is not moving. But it is a stable fixed point or not? How do you want to tell it? How do you want to test it? Any idea?
By checking points in its neighborhood.
Yes. In a easier way, just push it. Push both of them. So if you push it and take it here, what will happen? It will start coming back here and started doing like this, and eventually it will come back to here, right? Are you getting what I am trying to say? Suppose you pushed it from here, it will just keep falling. In any direction, if you push it, it will just keep falling. It will never automatically come back here. But if you push it
Yes,
from
sir.
here in any direction, it will
Yeah.
eventually
Come to the original. Yeah, come back.
Yes, it will come back. So we call this kind of fixed point is a stable fixed point, and this is unstable fixed point. Okay. So this is the same thing we are gonna do to test the stability. So this thing I just did, that pushing away, is called perturbation. You perturb the system, that means move away the system from this x star y star and check if it comes back or not. Okay. So how to do that? So you know x star and y star. Suppose you start at a very small neighborhood of x, like suppose this k. So very small neighborhood of x, that is h, and very small neighborhood of k, that is y, that is y star plus k. Okay. So dx dt becomes dx star dt, because h is a constant. No, sorry, x star is a constant. So dh dt, right? X star is a fixed point. H is the variable, like where you are, very small
Right.
perturbation, and dy dt
And
becomes
dk by dt.
dk dt.
Dk by dt.
And so the differential equations becomes dh dt equals f of x star plus h comma y star plus h, and dk dt becomes g of x star plus h comma y star plus h. Fine. Till this point you got what I'm trying to say?
Yes, sir.
Yes. Now we will do that thing, the Taylor expansion of this. So what it gives? F of x star comma y star plus h del f del x at x equals x star plus k del f del y at x star y star. At x star y star. Similarly, this is dh dt, and then dk dt becomes g of x star comma y star plus h del g del x star y star plus k del g del y x star y star till linear. Okay. Understood till this point? Okay.
Yes, sir.
Till this, now tell me what are these values?
Zero. Already they give.
Yes.
F of
Already
x star y star is
zero.
0.
So now look at this. I have dh dt, and this is some constant, this is also some constant, this is also some constant. So let's write it like this: a h plus bk
Plus dk
and dk dt equals
k by dt
ch plus dk.
ch plus dk.
Okay, so in general I can write dh dt dk dt in terms of matrix form, but this will be a b c d hk. Correct?
Yes, sir.
Yes. Now what are your ABCD? A was del f del x, del f
Dou f by dou x at x naught y naught.
del g del x, del j del y at x naught y naught. So this is called your Jacobian. Now dh dt dk dt,
About that.
it becomes j times hk. Okay. Now suppose you can diagonalize it. Okay. If you can diagonalize it and write j diagonal as sum lambda 1 0 0 lambda 2. Okay. Suppose you can diagonalize and write j as this form. So what does this becomes? dh dt dk dt is lambda 1 0 0 lambda 2 hk, and you get lambda 1 h dk dt is lambda 2 k, which gives you solution h of t is e to the power lambda 1 t and k of t e to the power lambda 2 t. Got it?
Okay, sir.
Now look, h and k are the small perturbation, right? So h or k are very close to your fixed point.
Right.
Now if these lambdas are positive, so h and k are how will it look? If lambda is positive, it is exponential growth,
Yeah.
and lambda are negative, then it will be decay. So this decay means if you perturb it, this decay means eventually h will, or k will go to 0, and if it is grows, it means it's go away from 0, which means if it decays, this small perturbation decays, we call it a stable equilibrium, and if it is goes away, we call it a unstable equilibrium. So that point we call a stable point or unstable point based on this lambda 1 and lambda 2. Any questions? This whole process is called linear stability analysis.
Okay.
This whole process of writing this Jacobian, calculate and this diagonalization, you can just keep all those diagonalization process and calculate this eigenvalue.
Yeah, lambda 1 and lambda.
Yes, if you calculate the eigenvalue, it will eventually like diagonalize it. Then at the diagonal elements, you will have this eigenvalue. So calculate the eigenvalues. So to like write it, linear stability analysis method is calculate J, calculate eigenvalue of J if real part of that eigenvalue lambda less than 0, stable, if real part of lambda greater than 0, unstable. Got it? This is how you do linear stability analysis.
Okay.
Fine, everyone?
Yes, sir.
Okay, so next let me come back to the question. First question. Is it correct or not? The size of Jacobian matrix is decided
Yeah.
by the total number of variables. It
Yeah,
is-
correct. Variable.
yes.
Right. Correct.
It is always a
Correct.
yes. So the option which is incorrect is this option,
Second option.
second option. Fine. So I have told you how to calculate Jacobian and stuff. Now there is this question. For a given model like this, there are more than one trivial steady states. The Jacobian about this, the non-trivial steady state is this. Jacobian about the trivial steady state is this. Eigenvalues about the trivial steady state are complex number. So you first calculate fixed points. Calculate fixed points and tell me what are the fixed points. Go ahead.
Voice not audible clearly.
I am not talking right now. I'm asking to calculate the fixed point. Do this and tell me what are the x and y. For that, these two are 0. Did you get it? If you got it, just raise. Tejinder says one is 0 0, Okay, let me just write.
0, 0 and 1 by 4, 1 by 3.
Anyone else got this answer?
I got 0, 0 only.
You got 0, 0 only. Okay. So let's see. X minus y plus xy. Anyone else is doing or not? And another is 3x minus 2y minus x.
Minus xy is equal to 0.
Okay. So 0, 0 is definitely 1. You can see.
Yeah.
Let me put your values. 1 by 4 minus 1 by 3 plus 1 by 12, which satisfied here. 3 by 4 minus 2 by 3 minus 1 by 12, which satisfied here also. So these two
Yes.
also satisfied. So this 0, 0 is called trivial, and this other one is called non-trivial. Okay.
Yeah.
So it says there are more than one non-trivial city states. So this is not correct because you got only one non-trivial. Right? Now calculate.
Sir, can you tell how to get 1 by 4, 1 by 3?
Oh, you want to know how to get 1 by 4, 1 by 3?
Yes, sir.
Okay. I think you multiplied and subtract, maybe, or just add it. What about if
Yeah.
you add these two? 4x minus 3y
Okay.
equals 0, right?
Xy is cancelled. 4x minus 3y is equal to 0. So that is 1 by
X
4 and
becomes 3
1 by
by 4 times y. So if
Okay.
you 3 by 4 times y minus y plus 3 by 4 times y square equals 0, right? So here you get 1 y equal to 0. I think here you can get this 1 by 3 minus 1 by 4.
Okay. Okay, sir.
Right?
Okay, sir. I got it.
Yeah.
I understood.
Yeah. So calculate the Jacobian. So del f del x, del f del y, del g del x, del g del y. Calculate it first, then put 1 by 4, 1 by 3, and tell me the answer.
Four by 3.
Okay.
The first row is 4 by 3 minus 3 by 4.
4 by 3
And the second is 8 by 3 minus 9 by 4.
So this option is correct.
No, because they are talking about the trivial steady state. This is about
Oh,
non-trivial.
this is trivial, then it is not correct.
Yes. The second one is also not correct because we have calculated about the non-trivial one and we are getting the C option.
Okay. So now you have to go for this eigenvalue thing. So trivial, what is the trivial steady state? They are asking for eigenvalue about the trivial steady state.
Yes, about 0, 0.
Yeah. Hello? Can you hear me?
Yes, sir. Yes, now we can hear you.
Sir, there has been a power cut here. So my Wi-Fi went away. I'm running on mobile network, so there could be lag or something. So anyway, did you calculate the eigenvalue?
We are calculating.
Okay. I think fourth option is the correct. There is a complex number coming up. Can you check? Whoever is calculating.
Yes, we are getting complex eigenvalues.
Okay. So then the last option is correct. Previous is a complex number. Fine, everyone? Shall I move on to the last question? Question 10. So this is your differential equation. You have to solve it manually. So you have to solve it and get it passing through one by one. Like the constant should be calculated based on what is the value of it at 1 comma 1. So how do you want to do it? Any idea? So there are like, see, differential equations have tricks to solve it. Like you have to make it look like a existing equation that is you know how to solve, right? So I'll tell you what the trick is. First, we need to change some variables. Okay. So let's see. You can write dx dy equals xy plus x square y cube. Correct? Now you substitute x equals 1 by z. Okay. So dx dy becomes minus 1 by z square dz dy. So are you following?
Yes, sir.
So look at this. Does it look like something you can solve? Do you know how to solve this kind of equation?
Linear differential equation.
Yes. Plus p of x y q of x equals 0. Do you know how to solve this kind of equations?
Yes, sir.
So does this one looks like that?
Yes,
So what is the solution of this? Do you remember?
we need to calculate the integrating factor and then solve.
So I think this is what you are talking about. And
Yes, e to the power this integral.
I think this solution looks like something like integral q dx dx. Probably the whole solution of this equation looks like this. I don't exactly remember, but y to the power px qx. Yes, this is the solution of it.
This is correct.
Yes. So can you do Do it. Like just the variable looks different. And just tell me what will be the
Yes, sir.
equivalent of px here.
Z into e to the power of y square by 2 is equal to minus 2 e power y square by 2 into y square by 2 minus 1 plus c.
What? Hold on. Z into e to the power. What will be here?
Y square by 2.
Y square by
Y
2.
dx.
They're already telling you the
Y dx.
integral, so that is y square by 2, e raised to power y square by 2.
No integration, sir.
That is already solved.
So integral q. What is
E
q?
to the power of y square.
Z into e raised to the power y square by 2.
And y cube.
By 2.
Minus y cube.
Minus y cube.
Yes, usually we write it as equal to qx, not equal to 0.
Okay. So minus y cube dy plus c. Is it correct what I have written here?
Yes.
Yes, sir.
And can you do this integration?
Minus 2 times of e power y square by 2 into y square by 2 minus 1.
Okay.
Minus 2 into
Minus 2
into e to the power of y square by 2
go ahead.
into y square by 2 minus 1.
Is it what you are saying?
You need to put a bracket on y square minus 1.
Y square by 2 minus 1 is only the bracket, right?
Yes.
Plus c. Plus c.
Now just put z equals 1 by x. This is will be your solution. Put back this 1 point, calculate c. And you will get it. This whatever she is saying, is it like anyone else is verifying? I am not verifying. I hope you
Yes,
guys
yes. No, it is correct.
verify. Okay. Fine. So I think if you put back c, you will get the answer. Maybe at the last
Yeah, it's
option.
verified. It's correct.
Okay. So is it the last option or what is the correct option? At about 1
C
Yes,
is
last
0, then y is
Last one.
last one.
Yeah, C is 0. Right.
Okay. Fine. So that was it. That was the last question. So mostly this week was about differential equations and all, and you should definitely go through the lectures. There will be, you will know how to form a differential equation based on the system you are talking about, and that's it. Any questions or any queries?
Sahil, sir, please show first question again. I missed that one. I'll take a screenshot.
Okay. It is an easy question. Yeah. Sure.
Thank you.
Okay. So this will be available. This recording will be also available. You can check it out later, and also this PDF of this whole thing, calculations. That do you have access to those, everyone?
Yes. Yes. We can have them from the page itself, the spreadsheet link.
Yes. Yeah. Correct. Okay then. Thank you for joining.
Where is the spreadsheet link? Can you tell me, please, ma'am, where is the spreadsheet link?
You just go to the course, open the course, and on the course layout page only, where we have all the weeks, you will see the problem solving session link also there. When you click on that, you can find the spreadsheet link.
Okay. Thank you, ma'am. Thank you. Sir, assignment 1 and 2, there are a couple of questions The answers are, I don't know, I have solved it, but they are different. Some confusion is there. So can you brief on that, the questions which were asked in assignment 1 and 2?
See, these are previous year's assignment. So this is like what kind of which ones are you talking about? Can you tell me?
No, Sahil sir, the results are out for week 1 and 2. So I think we will be able to discuss those also.
Okay. So actually, I don't have the questions. You
This year's course, but week 1, 2, the result is out
okay?
already on 8th.
Already on
But
the
there are certain confusions.
certain confusions. Okay. So
Um,
can you tell me the
Sir,
questions?
if you can open the course right now,
Okay.
is it possible for you to open the course?
I think so. Let me check.
Otherwise, we'll screen share.
The Wi-Fi is not stable. Okay. So I go in to. You can see my screen, right?
Yes.
Yeah, in this, if you go to assignment 1, week 1.
Sir, you have not joined the course.
Oh,
No, hold on. I'm just signing.
I think, ma'am, if you present, I think he will be able to. Or should I present?
Anyone you can.
So go ahead.
Hold on. Let me sign in.